Welcome to this lecture. So in this lecture we will understand the domain and range of a relation. So guys, from previous lecture we know that a relation R from set A to B is a set of all the ordered pairs which satisfy A related to B. Alright. Now the set of all the first elements of ordered pairs of R is called as domain, and the set of all the second elements of the ordered pairs of R is called as the range of the given relation R. Like for an example, if there was a set A which has elements 1, 2, 4 and 6, B which has elements 2, 8 and 12, and we define a relation R between A and B, which is, so here we want all the ordered pairs between A and B such that the element of A is less than the element of B. Alright, less than between A and B means A will be less than B. Alright, it is like A R B. This R will be replaced by the definition of relation, so it will be written as A less than B. This is the relation between A and B. Alright, so what are the ordered pairs? Let's write down. So if we write down the relation R, clearly 1 is less than 2, so 1 and 2. Here 1 is the element from set A and B, and 2 is the element from set B. Second can be 1 is less than 8. Third is 1 is less than 12. Then fourth we compare 2 with all these. So 2 is not less than 2, so 2 and 2 will not come. But 2 is less than 8, so 2 and 8 is possible. Similarly 2 and 12 are possible. Next 4 is greater than 2, so this will not come, but 4 is less than 8, so 4 comma 8 is possible. Similarly 4 comma 12 is possible, and with 6 again 6 comma 8 and 6 comma 12 will be possible because 6 is less than 8 as well as 6 is less than 12. So 6 comma 8 and 6 comma 12. So basically this is the relation R between A and B, where R is less than relationship between A and B. Alright, now domain. Definition says the set of all the first elements of the ordered pairs of R. So what are the first elements of the ordered pairs of R? All these circled one. This is the first element. All these are first elements. There are two elements in the ordered pair, so first one we are circling. In every ordered pair we are circling the first one. Alright, so now the domain is a set of all the first elements of the ordered pairs of R. So if I write down the domain, then domain will look like, what are the first elements? 1 1 1. We do not have to repeat, so we will just take 1. So 1 2 4 and 6. Alright, this will be the part of domain. And range, here R stands for range. This is not relation, this R stands for range. And R, range, the set of all the second elements of the ordered pairs of R. So what are the second elements? Basically these are the second elements. 2, 8, 12, 8, 12, 8, 12, all these basically. Alright, so basically 2, 8 and 12 are there in the second pairs. This will be 2, 8 and 12. Alright, so domain being the set of all the first elements and range being the set of all the second elements. Now you might be thinking that clearly domain is nothing but all the elements which are there in A, and range is nothing but all the elements which are there in B. But this might not be always true. Alright, like for an example, if I define a relationship say equal to between A and B, alright, so if R was equal to relationship, alright, if a relation R was equals to, then this will have elements 1, there is no equal to element which is equal to 1 in B, but 2 and 2 are equal, so this will come as one ordered pair. Second 4, nothing is equals to 4 here, nothing is equal to 6 here. Alright, so there is just one ordered pair in this relation. Alright, so now the domain will be set of all the first elements, this will be domain, and range will be set of all the second elements of this ordered pair. So there are just one elements here, so domain you will write as 2, and range you will write as 2 again. Alright, makes sense? So domain and range is actually dependent on the relation, and all the first elements of the ordered pairs, when they are written in the form of a set, that forms a domain, and all the second elements of the relation set, they form the range. This is range. Alright, this R and this R are different. I'm writing range to represent that it's not a relation, but it's a range of that relation. Alright guys, now let's do some questions. So here we are given a relation R, which is like this: 2, 0, 3, 1 and 2, 1. We have to find the domain and range of R. Alright, so clearly you can see that domain is nothing but set of all the first elements. So first elements are this, this and this. So domain will be equals to nothing but 2, 3. The 2 is repeated here again, so we will not write it 2 times, we will just write it once. So domain will have these 2 elements. And range will be all the elements which are, range means all the second elements of the ordered pair. So this and this will go in range, but again 0 and 1. Alright, because 1 we don't have to write it twice. Alright, so this is how we get the domain and range of a relation. Let's do another question. This is an interesting one. Here we are given set A, which has elements 1, 2 and 6. We are given another set B, which has element 1, 4 and 5. We are defining a relation R here, which contains ordered pairs A, B, such that A is an element of set A, B is an element of set B, and there is another relationship between B and A, that B should be a square of A. Alright, and we have to find the domain and range of R. So to find the domain and range of any relation R, first step is to write them in the roster form. This is currently written in set builder notation, so we have to write this in roster form. So relation R in roster form will be all the pairs of A and B such that B is a square of A. So first we will write 1 here, and we know that this element 1 is square of 1 because square of 1 is 1. So 1, 1 makes an ordered pair which satisfies this relation. Second, clearly 2 and 4 also makes, because square of 2 is 4. So this should be square of this element. This is A and this is B. So we are saying B should be square of A. So this relation holds for this ordered pair, similarly for this. I think only these two are possible for this one. Alright, because 6, there is no square of 6 available in B. Alright, so these are the only two pairs, ordered pairs, which are possible. Now you can write the domain and range. Clearly domain will be all the first elements, this one and this one, and range will be all the second elements, this one and this one. So we can say that domain will be equals to 1, 2, and range will be equals to 1, 4. Make sense guys? Alright.